Imagine yourself meeting someone for the first time. You start a conversation. Within minutes, you realize that it feels like you've known this person forever. You experience a natural, instant, and spontaneous connection. An affinity with them. You know you'll get along with them in the future. What if your monitoring strategy could work the same way? Meet R-Star Affinity. R-Star Affinity is your turnkey industrial Internet of Things solution for reliable, real-time data flow from your worksite to your desktop, all from a single vendor. Built for clients that care the most about critical asset data, R-Star Affinity is the integrated geotechnical solution for seamless data collection, communication, and presentation. R-Star Affinity, your single source, sensor to remote data connectivity solution.
Hello, everyone. Welcome, and thank you for your interest in Dingo's predictive maintenance solutions. My name is Rob Bush. Some of you may be aware that Dingo provides a holistic predictive maintenance solution to help your maintenance and reliability teams efficiently identify equipment problems and action work to correct them in both fixed plant and heavy mobile equipment environments. Today, I'm specifically going to talk about 3 ways Dingo is innovating to empower remote operations. Those 3 topics being the application of predictive analytics to predict the remaining useful life of equipment components, the use of digital inspections in our inspection app, and fully remote implementations as required by some of the travel challenges over the last year or so. Dingo has been on a journey over the last 6 years or more, bringing in-house our own data science team to leverage predictive analytics and the application of data science to deliver more predictable fleets for our customers. Customers in the field are currently using Dingo's models to prevent failures by addressing and correcting life-shortening conditions, maximizing return on assets by boosting productivity, and optimizing component replacements by identifying which components can be responsibly extended, as well as which components may require premature changes, thus maximizing the value of good parts while mitigating the risk of potential lemons in the fleet, all of which impact the AIC in your mines and in your mining companies. What's Dingo's approach to doing this? Well, customer collaboration is the starting point, whereby Dingo works with the customer to identify specific failures and potential indicators of them. Dingo's in-house data science team then works with Dingo's software engineers, as well as mining maintenance and reliability experts and analysts to confirm which are the primary indicators leading up to failure, and then develop the models to address and predict the remaining useful life of said components. Dingo also collaborates with academia to develop and test models, working with advanced mathematics and statistics experts at the Queensland University of Technology. One recent learning has been a pivot away from strict machine learning approaches to a Bayesian approach. This has enabled the expansion of consideration or improved the consideration of field expertise and experience in-house to Dingo, which has helped move away from a black box perception or approach and boosted customers' confidence in the field, since impacts to the remaining useful life estimates are more readily apparent. Dingo has been particularly focused over the last few years in wheel motors and final drives, as well as application in rod bearings and engines and others. Over time, Dingo looks to expand the offering, thus including more onboard technologies as those technologies become more readily available and present in the market, as well as any other condition monitoring data. The overarching goal is to deliver a highly graphical interface that helps teams quickly identify risks and prioritize component replacements. So what does the practical application of predictive analytics look like in the field? Recently, Dingo had a customer who was seeing approximately a 30% reduction in final drive life, having a cost impact of around 1.7 million US and significant downtime incurred, particularly in the case of in-pit failures, having an exponential effect on productivity as well as repair costs. Dingo collaborated with site experts at the customer site to determine the failure modes and get ahead of the contributing conditions, then developed a model, specifically using oil analysis only at this stage, to continually predict the remaining useful life at any moment in the equipment's life cycle. This had a considerable impact on the maintenance team's efficiency and ability to reduce their ever-increasing backlog of maintenance work, as well as improve availability and create a more predictable operating environment. Dingo software engineers have also been working diligently over the last 2 years to improve functionality of our digital inspection app. We've seen incremental growth in the adoption of digitized inspections and have noted that this is a powerful way to establish a collaborative link between field technicians and reliability and planning teams at site. As can be seen here, inspection instructions can be included in either PDF or image files, thus to help guide field technicians in how to go about collecting the useful information or the critical information in making decisions on component replacement or other maintenance work that is required. As can be seen here, field technicians are able to mark up and clearly annotate pictures, condition ratings can be assigned, and then automated reports are generated and sent to relevant parties according to track a configuration by which relevant parties can be installed or entered into Traca based on each component to ensure they receive critical information around work that needs to be completed. Finally, these automated reports are sent via email to the recipients, and these include condition ratings, pictures, and comments. Traca also receives this inspection data as soon as the mobile device on which this inspection has been taken returns to internet coverage. Thus, work can be seamlessly actioned as necessary based on these inspections, ensuring that inspections are acted upon and prioritized for work. This has really helped to facilitate collaboration and efficiency amongst maintenance and reliability teams and how they interact with technicians in the field or even interact while off-site if necessary. Many miners and suppliers are forced to innovate in 2020 on how to deliver their services without the ability to travel to site, and Dingo was no exception to that need. Dingo's processes evolved, and in that process, or in the evolution of that process, Dingo fully executed remote implementations to ensure our customers could reap the full benefit of Dingo's solutions. Some of the learnings were requirement of longer training schedules to compensate for the need of shorter training sessions, considering the potential for reduced attention span in a virtual learning environment. Also, project plans were adjusted to better realign with constrained resources on the customer's end, particularly in the case of interacting with IT groups, and for instance, in the case of condensing or synthesizing the process of building onboard interfaces to address and consume or consider onboard data, as well as the need to integrate or projects to integrate with the customer's ERP. Dingo created or improved digital resources for mobile app training and also developed more custom apps to better fit with local teams rather than trying to train workarounds or train in existing apps. And finally, a train the trainer approach was taken to condition management meetings, so the bi-weekly meetings could be led by local customer resources after being trained on how to lead these meetings by Dingo resources rather than Dingo trying to lead these meetings in a virtual capacity. So what were some of the key takeaways from these learnings? Well, breakdown avoidance events were still logged within the first 2 weeks of deployment of the Traca database. One benefit of this is the ability for local teams to learn on a real-world scenario during implementation phase. And overall, it's also worth noting that the cost avoidance break-even was achieved within 6 weeks and before implementation was even achieved, thus highlighting the ability to complete an implementation while also reaping the benefits during the course of that implementation. Thank you all for your time. If you have any questions, feel free to contact me directly at the email on the screen or visit us at our website. We look forward to hearing from you. Thank you very much.
Imagine yourself meeting someone for the first time. You start a conversation. Within minutes, you realize that it feels like you've known this person forever. You experience a natural, instant, and spontaneous connection. An affinity with them. You know you'll get along with them in the future. What if your monitoring strategy could work the same way? Meet R-Star Affinity. R-Star Affinity is your turnkey industrial Internet of Things solution for reliable, real-time data flow from your work site to your desktop, all from a single vendor. Built for clients that care the most about critical asset data, R-Star Affinity is the integrated geotechnical solution for seamless data collection, communication, and presentation. R-Star Affinity, your single source, sensor to remote data connectivity solution.
I love coming to IMARC. The buzz here is great. There's so many new and interesting people to see, lots of great opportunity to network.
The value of IMARC to us is that we can get an update of a lot of the companies that we have invested in or are looking to invest in. In a broader picture, we can get an update on the new technology that's happening in the mining industry.
I've been to a lot of conferences and this is probably the best I've seen. It's definitely the biggest for sure.